So we're going to talk about finding the real zeros of a polynomial function. Remember that real zeros show up on the graph and imaginary zeros do not. So in order to find real zeros, we already know that we can factor. We already know that we can graph it. So there's a third way that we're going to learn how to do it, and that's by using long division. And so this first example, we've got 6x cubed minus 19x squared plus 16x minus 4, and it's divided by x minus 2. There's a really cheesy video posted on your Canvas if you want to view that to review long division. It's not polynomial long division, but it is long division, and we're going to follow the same process. So in Math 3, if you have seen this, you might have seen it as the polynomial long division or using the box method. If you know the box method, you can use it. If not, I'm just going to show you the regular polynomial long division. So we're going to put the big long polynomial, the dividend, underneath the house. We're going to put the divisor outside, and the answer will be the quotient. And we're going to follow a couple of rules. So if you just like to follow the process, just follow the process. If you like to have a list of rules, you're a little more systematic, then I will have those for you too. So we're going to divide the first term. The first term of the numerator. By the first term of the denominator. And start your answer. So that would be if we wrote the original example as a fraction. So we're going to take this first term, 6x cubed, divided by x. And so x times what gives me 6x cubed? Well, 6x squared. So we're going to put it over the x squared column. Step 2 is to multiply the denominator by the answer. So multiply denominator by answer. Answer, and put under the numerator. So we've got 6x squared, we're going to multiply it by x. 6x squared times x gives me 6x cubed. 6x squared times negative 2 gives me a negative 12x squared. I'm going to draw my line and subtract. When we subtract, this is the place where we can get really, this is where we can get really messed up, because what happens is when we subtract, sometimes we forget to distribute it to both terms. So it's the opposite sign for negative, for the positive 6x cubed, and it's the opposite sign for negative 12. So make sure that you're really careful there. When we do that, when we subtract, the first term is always going to cancel. And then we'll bring everything else down. So negative 19x squared plus 12x squared is a negative 7x squared. And bring down the next term. All right, and so then we're using this negative 7x squared. So x times what gives me negative 7x squared? Well, a negative 7x. So we'll follow the same steps. So we'll say repeat. Negative 7x times x is a negative 7x squared. Negative 7x times a negative 2 is a positive 14x. Draw our line, and we are going to subtract. Oh, so since that, sorry. We've got a minus sign. So that negative becomes a positive, and this 14 becomes a negative. So when we subtract, we get our canceled out first term, and we've got 16x minus 14x. which gives me a 2x, bring my last term down. All right, x times what gives me 2x? Well, that would be a 2. 2 times x is 2x. 2 times negative 2 is negative 4. Draw our line and subtract. When we subtract opposite signs, and what happens is everything cancels out. And so we know that my final answer is 6x squared minus 7x plus 2. So if you had a number here, that would be the remainder. If your remainder is 0, we can say our divisor, well, maybe. Divisor is a factor. So we can say x minus 2 is indeed a factor of 6x squared minus 6x cubed, sorry, original problem. 6x cubed minus 19x squared plus 16x minus 4. So lots of things there. That's your long division. We'll do a couple more examples. And like I said, if you know the box method and would prefer to do that, then you can do that. Division isn't that bad, except for when it's really easy to make a mistake. And sometimes we get going really fast and it does end up being pretty difficult. All right, so we've got x cubed minus 1 divided by 2x minus 1. So we'll have 8x cubed minus 1 underneath the parentheses, but what happens is that we're missing some of the terms, so it's not in descending order. So what we have to do is use placeholders. So we'll have a 0x squared plus 0x minus 1. Now we have each term represented. And then we'll start it off the same way. So we'll say 2x times what gives me 8x cubed? Well, that would be a 4x squared. Put it in the x squared column, and then we'll multiply. So 4x squared times 2x gives me an 8x cubed. 4x squared times a negative 1 gives me a minus 4x squared. Draw my line and subtract. When I subtract, make sure that we distribute the negative everywhere. It's a negative. This becomes a positive. And then my first term should simplify to 0. 8x cubed minus itself is 0. And then we've got 0 plus a 4x. So we end up with a 4x squared, and then we're going to bring down a 0x. That's kind of weird to bring down nothing, but we want to make sure that our final answer is correct. So that's why we bring down the next term even though it's a 0. So to get from 2x to 2x squared, we multiply by a positive 2x, and we'll multiply. So 2x times 2x is 4x squared. 2x times a negative 1 is a minus 2x. All my stuff is lining up. Draw my line and subtract. So we've got a negative 4x and a positive 2x. When we do that, my first two terms cancel, and I've got 0x plus 2x. So we've got a 2x, bring my last term down. Well, what do you know? 2x minus 1 and 2x minus 1, they are the same, but we'll finish it all the way through. So 2x times what gives me 2x? That'd be a 1. When we draw our line and subtract, we should see that everything ends up canceling. And so my answer is 4x squared plus 2x plus 1, and there's a remainder of 0. So not only have we done long division, but we can also say that 2x minus 1 is a factor. And that's the remainder rule, and we won't really deal a whole lot with that, but it does exist, so I want to make sure that you are aware of it. So we'll do a couple more examples. So So we've got negative 2 plus 3x minus 5x squared plus 4x cubed plus 2x to the fourth divided by x squared plus 2x minus 3. And so what we want to do there is go ahead and divide it. And so to divide it, we want to make sure that the dividend is in descending order. So we'll start with 2x to the fourth, have plus 4x cubed minus 5x squared plus 3x minus 2, and it's divided by a 3-term polynomial, so a trinomial. Same process. We're still trying to figure out what multiplied by x squared to give me 2x to the fourth. That would be a 2x squared. So 2x squared times x squared is 2x to the fourth. 2x squared times 2x gives me 4x to the third. 2x squared times a negative 3 gives me a negative 6x squared. Draw our line and subtract. When we subtract, make sure that we distribute the negative. And then we'll combine like terms. My first term cancels out, which is really good. 4x cubed minus 4x cubed is a 0x cubed. And we're going to write it as 0 just because that is how we're going to multiply. And we want to make sure that we've got all the right terms. And then negative 5x squared plus a 6x squared. Positive x squared, bring my next term down. All right, and then we've got x squared times what gives me 0x cubed? Well, that would be a 0x, technically. We'll just have 2x squared plus 0x, and we'll have it in descending order. So 0x times x squared plus 2x minus 3, we're actually going to get 3 of those terms, 0 terms. Draw a line and subtract. It's kind of weird. So make that one a positive. And then when we bring it all down, we end up getting an x squared plus 3x, and then we'll have a minus 2. So now that we've brought all of our terms down, we should be in the final stages. So x squared times what gives me x squared? Well, that would be a 1. So 1 times x squared is x squared. 1 times 2x is 2x. And 1 times negative 3 is negative 3. Draw our line and subtract. And then we will combine like terms. So my first term cancels out, and I am left with an x plus 1. So there's nothing else to bring down, so we find that x plus 1 is the remainder. So this tells us a couple of different things. It tells me that x squared plus 2x minus 3 is not a factor of that polynomial. And it also, what we want to do with that remainder is put it with our polynomial, and we'll have plus our remainder over my original divisor. So my final answer, when we divide it out, would be 2x squared plus 1 plus x plus 1 over x squared plus 2x minus 3. And I know that long division is kind of a lot right now, but we're going to practice with it a lot. We'll have a quiz on it so you can see it before your test. Just make sure that you are working through the homework the best that you can. So I've got one more example for you. So we are going to show that x minus 2 and x plus 3 are factors of 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18. All right, so in order to show that, that means that we have to divide and make sure that our remainder is 0. So we're going to start with our 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18 underneath the house. And you can divide it by either one. It doesn't matter which one you go by first. And we'll divide by x minus 2. So go ahead and pause the video. See if you can divide it without me. So I've got x minus 2. I'm going to work through it. Hopefully you've already paused. Hopefully you've already solved. So just make sure that you have got a good grasp. All right, so x times what gives me 2x to the fourth? Well, that would be a 2x to the third. 2x to the third times x is 2x to the fourth. 2x to the third times a negative 2 is a minus 4x to the third. Draw my line and subtract. When I subtract, all of these signs change, and my first term cancels out. All right, so 7x cubed plus 4x cubed is an 11x cubed. Bring down my minus 4x squared. All right, x times what gives me 11x cubed? Well, that would be an 11x squared. 11x squared times x gives me 11x cubed. And a minus 22x squared. Draw my line and subtract. When I subtract, all of those signs change. My first term should cancel. Negative 4x squared plus 22x is a positive 18x squared. Bring down my negative 27x. All right, x times what gives me 18x squared? That would be a positive 18x. When I multiply 18x by x, I get an 18x squared. 18x times a negative 2 is a minus 36x. Draw my line, subtract. All the signs are opposite. So my first terms cancel, and I've got negative 27x plus 36x. And what do you know? That gives me a 9x. Bring down my last term, minus 18. All right, so x minus 2, x times what gives me 9x times 9. So 9 times x is 9x. 9 times negative 2 is negative 18. Draw my line and subtract. And when I do that, everything cancels. My remainder is 0. So we can go ahead and say x minus 2 is a factor because my remainder is 0. And we have proven it. So then what we can do, if you rationally think about it, if you divide out the x minus 2 and we get this quotient 2x cubed plus 11x squared plus 18x plus 9, it should theoretically divide by x plus 3 if we're trying to show that they're both factors. So you can start back at the beginning with your 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18 if you want to and divide using that polynomial, or you can use your quotient. Especially since x minus 2 is a factor, we should be good to go using that little bit of a smaller polynomial. And then we are also proving that x plus 3 is a factor. So we'll divide out the same way. Go ahead and pause your video and see if you can divide it out. And I'm going to go ahead and work through it. So x times what gives me 2x cubed? That would be a 2x squared. 2x squared times x gives me 2x cubed. 2x squared times 3 gives me a 6x squared. Draw my line and subtract. First terms cancel out. So 11x squared minus 6x squared gives me a 5x squared. Bring my next term down. X times what gives me 5x squared? That would be a 5x squared. 5x times 3 is a 15x. Draw my line and subtract. My first terms cancel out, and I've got 18x minus 15x. Gives me a 3x. Bring my 9 down. X plus 3 times what gives me 3x plus 9? Well, I know 3 times x is 3x. 3 times 3 is 9. Draw my line and subtract. And when I do that, everything cancels. My remainder is 0, so I can say that x plus 3 is a factor. So if we were to write this function as a factored form, we have x plus 3, we've proven that, x minus 2, we've proven that, and 2x squared plus 5x plus 3. But what we know is that 2x squared plus 5x plus 3 is a trinomial. And so hopefully you should be thinking, well, that's not completely factored. I can factor it further. So we will. We'll factor it further. So we've got the 2 times 3 gives me 6 and 5. My two numbers that multiply to give me 6 but add to give me 5 would be 2 and 3. Make sure you can factor that on your own. Factor by grouping. And so I actually find that my completely factored form is x plus 3 times x minus 2 times 2x plus 3 times x plus 1. That would be completely factored. All your factors are binomials. Which means that if you were to list out all of your zeros, you would have a negative 3, a negative 3 halves, a negative 1, and a positive 2. I believe that your homework asks for a factored form as well as zeros, so make sure that you work through and follow the instructions.